Okay, so same thing as before. We are on 2B here. Make sure you do these on your own. We're going to skip one here, but do these on your own and pause right now, try them on your own, and then come back and watch me. So that's the way you're going to learn the most. So if you haven't even tried these yet, stop the video, go do them, and then come back. All right, so assuming you have done them, all right, so let's look at these. So the first one says, number 2, Benton used 3/4 cup of butter to make a batch of cookies. He rolled the cookie dough into a rectangle. Now Benton wants a portion of dough that contains 1/4 of a cup of butter. How could Benton cut the dough? Okay, so we know that, he made, here's his bowl, right, and put all his ingredients in there, right, stirred it all up, beautiful drawing, and rolled it all out. Okay, and we know that this dough right here, all rolled out in a nice rectangle, has 3/4 of a cup of butter in it. And again, that butter has been mushed and stirred, so it's equally spread throughout this dough. Okay, and so the question is, now Ben wants a portion of the dough that contains 1/4. So again, this goes back to that iteration or groups. This is 3 sets of 1/4. So if I cut this into thirds, I know that if the butter's been mixed really well, that this would be 1/4 of a cup of butter would be in this section, 1/4 of a cup would be in this section, and 1/4 of a cup would be in this section. And that would all add up to 3/4 cups. So how could he cut the dough? He could cut it into thirds, which would be 2 cuts. Remember, it always takes 1 less cut to make that number of sections. So if I want 3 sections, it takes 2 cuts to make 3 things. And so then 1/3 of the dough should have 1/4 of a cup of butter in it. All right, let's look for number 3 for A. It says the yellow hexagon tile is 2/3 of a bigger area. Use pattern tiles to make what could be the design. Explain your reasoning. Okay, so again, in this problem, all right, so this is problem 3A. So in this problem, we're saying that this guy is equal to 2/3, and again, it's an area model. So this is 2/3 of the area of something bigger. All right, so if this is 2/3, if I take my pattern blocks, my other ones, and I look, I am like, okay, so my 2, remember this is 2 sets or 2 groups or 2 iterations of 1/3, and I can see that I have 1 there and 1 there. So suddenly I know that this guy is worth 1/3, all right? And so in the directions it says use pattern tiles to make what could be the design. So if this is 2/3 of the area of a bigger design, then I know that I need to build up to 3/3 to get the area of the whole design. So I could do that a couple ways. One is I could do these together, right? So I could take this and maybe put that on top, because if this is 1/3, 1/3, 1/3, I get my 3/3. So that would be totally legal, totally okay. The other thing I could do is I could maybe make a design like that, okay? Because again, these 2 together make my 2/3, and this makes 1/3. So this design would also be 1/3. Now, do I have to have a hexagon in there? The yellow hexagon, 2/3 of a pattern tile design, use pattern, okay. The other thing I could do is say I feel like I have to use this. Then I need to build 1/3, and I know that my 1/3 is this. So instead of using my trapezoid, I could be like, well, I do know that 3 triangles is the same as 1/3. So I could take my picture and take those, and I know that this would have an area of the whole design, because this would be my 2/3, and these 3 together would make my 1/3, which would make my whole. The other thing I could do is I could be like, okay, well, let's see, this guy and a triangle covers up my trapezoid. So if I have a hexagon, I know I have 2/3 of my design. And these two together make my 1/3. So again, I could make some design like that. And I know this is my 2/3 and 1/3, and I get my whole area. Okay, so there's more, I mean, tons of answers there. But as long as you have something that makes a hexagon and something that makes a trapezoid together to add up to all that 100% or 1, you're fine. Okay, so it kind of depends on how you want to set that up. All right, so let's look at the next one. Part B, what if your yellow hexagon is 3 halves of another design? Okay, so now suddenly this guy is worth 3 halves. Now again, you have to think about the meaning. That is 3 iterations or 3 sets, so 3 iterations of a half. And so to me, I am like, oh, well then suddenly this doesn't work anymore because I can't fit 3 of these in here. I need to find a shape that I can fit 3 of them in. And so it looks like I have maybe 3 rhombi here. So there we go. And again, rhombuses is legal. So you could say 3 rhombuses or 3 rhombi. But again, I know now that this is the value of a half. So this guy is worth a half. So using this guy to find my unit fraction, and my unit fraction is a rhombus and it's worth a half. And so the goal is to build a shape to figure out the original shape. Well, the original shape would have to be 1, which is 2 sets of 2, so 2 iterations of a half. So it would have to be something like that. Now again, it could be anything that has the same area. So for example, if I know that 2 triangles have the same area as a rhombus, I could use a rhombus and then maybe put 2 triangles. And again, it could be in a weird way. That's totally fine. I can make it look like a cat, actually. There you go. So then this shape is still equal to a whole or equal to an area. And again, if I want to replace this guy with 2 more triangles, I could do that too. And do, you know, I could even do maybe a zigzag or a shape like that. And I know, because I know a half is a rhombus, and so I know this is 2 iterations of that. So again, lots of different answers. I could also replace this guy with that because they have the same area. So then if I did this, that would also equal a whole. So the goal is to figure out the area of what your unit fraction is and then build up to what you need. But you can do that area in a lot of different ways. All right, let's look at C. What if the yellow hexagon is 6/10 of the area of another design? Okay, so let's flip the page. So this time, this is not worth 1. It is worth 6/10. And so again, that is 6 sets or 6 iterations of a 10th. So again, my numerator is my number, which I know that I could use 6 triangles to cover this guy up. And so my unit fraction is my triangle this time. So there's what I have. So I know that 1 triangle is my unit fraction, which is 1/10. That's my unit. All right, so now I want to build up to what? What if the yellow hexagon is 6/10? What is the area of the design? So I, again, want to get back to my whole again. So I want 10/10. So I could just draw, 10 triangles. I mean, I could do that. So I could draw, 10 triangles. That would be fine. The other thing is I know that my hexagon is worth, what, 6? 6/10. So then I could do 7/10, 8/10, 9/10, and 10/10. And I would know that that is a whole because I have this guy, which I know is 6, 7, 8, 9, 10. 10/10 would equal my whole area. Now, again, I can replace any of these with equal areas. So for example, if you don't want this guy in here, you could replace it with this guy and this, and you would still have the same area, 3, 6, 7, 8, 9, 10, 10s. And it wouldn't have to be in this order. Areas movable. So as long as I, you know, if I move the shapes and do this, I still know that that area is 10/10. I could replace these guys, both of them or one of them, doesn't matter. I know that these are the same as a rhombi, so if I wanted to, I could change that up to maybe that design. If I wanted to, I know 3 triangles equals this, so I could take this guy away and maybe add 1, 2, 3 triangles. So again, I have 3, 4, 5, 6, 7, 8, 9, 10, 10. So as long as your shape has 10 triangles would fit in the area, that's your whole. So any of those designs, again, tons and tons and tons of different possibilities. All right, and then let's look at number 4. Okay, number 4 says, suppose 3 yellow hexagon are 2/7 of the area, use pattern tiles. What could be the design? Okay, so, and again, explain. So now I have 3 of these guys, and the 3 of them together equal what? 2/7. Okay, so 2/7. So I know that that means 2 sets of what? 1/7. All right. So if you think about that, if I cut it in the middle, is everyone okay with that? I would have 2 sets. So this guy and this would be 1/7. This guy and this would be 1/7. All right. So I know, let me grab this guy with this would be 1/7. That is my definition of 1/7. So now if I want a whole design, I need to get up to 7/7. Okay. So again, I don't know how many shapes I have here, but we'll find enough. So 3 of these, this would be 2/7. I could do that again to get 4/7, do it again to get 6/7, and then combine it with this. All right, so I am going to try that. All right, I need another piece of paper here. So let's see, 3, so this is 2/7. So there's 2/7 right there. And then I'm going to add another set of 3 to my design. So there's 1, 2, 3 again. Kind of a honeycomb design. That's another set of 2/7. All right. And then I have what? Another set of 2/7. Okay. So now I'm up to what? 6/7. And remember we did the design where, and again, I'm dropping stuff on the floor, but half of it, remember, is this, right? 1.5. So 3 is equal to 2/7. So 1/7 is if I cut that in half. So this is exactly what that is, cut in half. So I'm going to just add this in there. There's my 1. I might just shove it in there. That's my 1/7. Okay, and that would add up to my whole, this would have to be your original design for this to be 2/7. Okay, because you'd have 2/7, 4/7, 6/7, and then a half would give you your 7/7. Now, if you don't like this design, again, you can trade area and it's totally fine. So if you're like, well, Julie, that's not the prettiest design I've ever seen. Let's be more creative. Okay, well, let's take away 2 trapezoids equals a hexagon. So I might just take one of these guys away. I'm not changing the area, but I'm just going to distribute it a little differently. So maybe I like that better. Maybe I want to replace this guy with, again, 2 trapezoids. So maybe I'll put one here and maybe put one here. Okay, and maybe I still think it's a little on the boring side. So maybe I am going to take 3 rhombi, and I'm going to say, well, I'm going to replace this guy with my 3 rhombi, and I can either put them all together in the shape that it was, or I can move them around. So I could put this rhombi maybe up here and put another one off to the side. That doesn't matter. So the main idea is figuring out what 1/7 is. And if you don't like the way I did it, the other option is to cover these with trapezoids, and I might run out of time here, but cover these all with trapezoids, and then know that 1.5 would be this many trapezoids. And so you could define these